This is the second video on areas under a curve. Let's try to sketch the right-hand sum over the interval from -1 to 3 using 4 rectangles. So I've given you a graph of the function, but I didn't tell you what the function is. So in this case, I don't really care what the actual numerical answer is. I just want to sketch the rectangles, and I want to show that I'm using the right-hand sum. So notice that I only care about the interval from -1 to 3. So I'm going to mark off those endpoints. And then I want to use 4 rectangles. So I've marked off in purple here the tally marks that I need to create 4 equal sized chunks. Now I want to do a right-hand sum, so I'm going to use the right endpoint for each interval in order to determine the height of my rectangles. For the first rectangle, we see that the right endpoint is at x equals 0. So I trace up until I hit the curve, and then I move to the left and trace back down. For the second rectangle, we see that the right endpoint happens when x is 1, so I'm going to trace up until I hit the curve, and then trace to the left. For the third rectangle, the x value is at x equals 2. I trace up again until I hit the curve and draw it to the left. And for the fourth rectangle, this right endpoint is at x equals 3, so I trace up until I hit the curve, and then trace over to the left. So this is my final answer. This is the right-hand sum over the interval from -1 to 3 using 4 rectangles. Now let's try sketching the left-hand sum over the interval from -1 to 3 using 4 rectangles. So just like before, I'm going to mark off the interval from -1 to 3, and I'm going to mark off 4 equal-sized chunks. So again, they're going to happen at x equals 0, x equals 1, x equals 2, and then the two endpoints, -1 and 3. Now for the left-hand sum, I want to use the left-hand endpoint in order to determine the height of the interval. So you'll notice that for the left endpoint of the first rectangle, that happens at x equals -1. So I use that x value to determine the height of the function. For the second endpoint, or for the second rectangle, the left endpoint is at x equals 0. So I use that endpoint to determine the height of the second rectangle. For the third, the left endpoint happens at x equals +1. So I use that to determine the height. And for the fourth, the left endpoint happens when x is 2. So I use that to determine the height. So you can see that even though we used the same type of idea in each of these cases, we ended up with 2 very different pictures. Let's let f of x be -x² plus 9, and let's try to approximate the area under f over the interval from -2 to 2 using 4 rectangles and right-hand sums. So here's a graph of the function, and we're trying to go from -2 to 2, and we want to find the area under the curve between these two red lines. So I'm going to start by splitting off the x-axis into 4 equal-sized chunks, and because we're using right-hand sums, I'm going to use the right-hand endpoint to determine the height of each rectangle. So here I've labeled my rectangles 1 through 4. Now we want to find the base of each rectangle. We've set it up so the base of each rectangle is the same. We're going to take the total length of the interval, which was 4, divided by the number of rectangles, which again is 4. So the base of the ith rectangle is 4 divided by 4, which is 1. The right endpoint of the ith rectangle is going to be found by starting at -2 and moving over the base I times. So we get -2 plus, we've moved over I times, and each time we move over the length of the base, which is 1. So -2 plus 1i. Just for example, for rectangle 1, the right endpoint, we start at -2 and we move over 1, so the right endpoint happened when when x is equal to -1. The second rectangle, we've moved over 1 again, so we've moved over from -2 2 times, so the right endpoint is at x equals 0. For the third rectangle, we've moved over 1 again, so the right endpoint is at positive 1. And for the fourth rectangle, we've moved over 1 again, so the right endpoint is at x equals 2. The height of the ith rectangle is then found by plugging in the right endpoint into the function. Our function in this case is f of x equals negative x squared plus 9. So everywhere that I see an x in that function, I'm going to plug in negative 2 plus I. So I have negative 2 plus I quantity squared plus 9. If I FOIL it out, I get negative 4 plus 4i minus I squared plus 9. And this simplifies to negative I squared plus 4i plus 5. So the area of the ith rectangle is going to be the base, which is 1, times the height, which we just said was negative I squared plus 4i plus 5. Now we simplify this by finding the total area as I goes from 1 to 4. Notice that the thing inside the sum is actually the area of the ith rectangle. And remember that I is counting the rectangles, so I goes from 1 to 4. We can pull a negative out of everything, so I have a negative, sum from 1 to 4 of I squared. Now I can pull a 4 out of the second term, so I have plus 4 times the sum as I goes from 1 to 4 of I. And then the last one's just a constant, so I'm going to leave it alone. So plus the sum as I goes from 1 to 4 of 5. So I end up with negative, and then the formula for I squared, plus 4 times the formula for I, which is just n times n plus 1 over 2, plus 5 times the formula for the sum of from 1 to 4 of just 1, which is 5 times 4. So we can simplify everything and we end up with negative 30 plus 40 plus 20, or positive 30. So the area under this curve is approximately 30. Now notice that we're going to have a little bit of error because in some cases the rectangles were bigger than the curve, and in some cases the rectangles were smaller than the curve. In general, if f of x is greater than 0 on an interval from a to b, the area under f of x on the interval from a to b with n rectangles using the right-hand sum is given as follows. We take the base of the ith rectangle by finding the length of the total interval, which is b minus a, divided by the number of rectangles, which is n. We can then find the right-hand endpoint of the ith interval by starting with a and moving over I times the base. So a plus I times the base. This is a tricky concept for a lot of students. So notice that if I called the base m, and here I've marked off from a to b a whole bunch of intervals of the base. If I start at a and I want the right-hand endpoint of the first rectangle, I have to do a plus m. If I want the second interval, I have to do a plus m plus m. If I want the third interval, I have to do a plus m plus m plus m, and so on until I get to b. The height of the ith rectangle is given by f of whatever the right endpoint is. So f of a plus I times b minus a over n. And finally, the area of the ith rectangle is just the base, which is b minus a over n, times the height, which we just said is f of a plus I times b minus a over n. We then find the total area by adding up from I going from 1 to n, because I counts the rectangles, of the area of the ith rectangle. And this is the approximate area under the curve. We saw in the first video that if we wanted the exact area under the curve, the final thing that we would have to do is take the limit as the number of rectangles goes to infinity. So the exact area under the curve is the limit as n goes to infinity of the sum as I goes from 1 to n of b minus a over n times f of a plus I times b minus a over n. Unfortunately, this looks really scary, but it's not actually as bad as it looks. You are going to be expected to know how to do everything on this slide for the final exam. Most likely, I'm going to be asking you to write me a small essay explaining how you would find the exact area under a curve on a given interval with n rectangles and using either the right or left-hand sum. Let's try another example. So let's find the area under f of x equals x cubed on the interval from 1 to 4 using 9 rectangles, and this time let's do the left-hand sum. The base of the ith rectangle is going to be the length of the whole interval, which is 3, divided by the number of rectangles, which is 9. So we end up with 3 over 9, or 1/3. The left endpoint of the ith interval is going to be given as follows. We're going to start at 1. Notice that the first interval is actually going to use 1 as its left endpoint. The second interval then is going to be 1 plus 1 times the base. The third is then going to be 1 plus 2 times the base. The fourth is 1 plus 3 times the base, and so on. So that means that the ith one is going to be 1 plus I minus 1 times the base, because each time we were using one number smaller than the number of times we wanted to move over, I. The height of the ith rectangle then is going to be f of this left endpoint, so f of 1 plus I minus 1 times 1/3, which is the same as 1 plus I minus 1 times 1/3 quantity cubed, and I'm not going to bother expanding that. The area of the ith rectangle then is the base times this height, and the total area is then the sum as I goes from 1 to 9, because I counts the rectangles, of 1/3 times 1 plus I minus 1 times 1/3 to the third. In general, if f of x is greater than 0 on the closed interval from a to b, then the area under f of x on a to b with n rectangles using the left-hand sum is given as follows. The base of the ith rectangle is going to be the length of the entire interval, which is b minus a, over the number of rectangles, which is n. The left endpoint of the ith interval is a plus I minus 1 times the base. And the way that we see this is that if I number the rectangles 1, 2, 3, and so on, the first rectangle actually just uses a as its left endpoint. The second rectangle uses a plus 1 times the base. The third rectangle uses a plus 2 times the base, and so on. The height of the ith rectangle then is f of the left endpoint, and the area of the ith rectangle is the base times the height. The total area is then the sum as I goes from 1 to n of the base times the height. And finally, if we wanted the exact area, I could take the limit as n goes to infinity. Just like I said with the right-hand sum, please know this for the final exam. And if you have any questions, please do come ready to ask them in class. I'm more than willing to help you.